Welcome students. In this video, we're going to find the area bounded by the graph y equals negative 4x plus 5 on the interval 0, 1 and the x-axis. So the first step is to find your endpoints and your xi. So the way we do it is like this. So we let zi equal to a plus I delta x. Where a is equal to your left endpoint, 0, and your delta x is gonna equal to what you do is this is your b, this is your a, and your b, so you do b minus a over n, with the delta x represents your division, your partition. So b minus a, so that would be 1 minus 0 over n. This is just equal to 1 over n. Then your xi, the one I'm gonna tell you where we're gonna use it. So we're gonna do ci is equal to a is 0, so we do I times 1 over n, which is equal to I over n. Okay, so that's your first step, finding those things. The second step is to actually compute the area. So area is gonna equal to lim as n approaches infinity of the sum I equals n, I equals 1 all the way to n of f of xi times delta x, where xi is the same thing as your ci that we found before. So okay, so now we plug in what we need, lim as n approaches infinity of the sum I equals 1 over n. So notice f of xi, we're gonna plug in xi into here, so that's gonna equal to negative 4. Remember, well, we found that ci is equal to I over n, so we're gonna plug in I over n plus 5. Then delta x is 1 over n. Now we do some manipulation here, so let's do that manipulation. Let's do it on the side here. Okay, so that would be equal to negative 4 over I n plus 5, and then this is multiplied times 1 over n, so that's equal to this becomes okay, so this becomes negative 4 I squared over n squared plus 5 over n. Okay, so now let's look at how we're doing here. So lim as n approaches infinity of the sum I equals 1 over n over negative 4 I over n squared plus 5 over n. So now what we can do is separate the sum. So we're gonna take out each term, so I'm gonna leave out the constant on the outside, negative 4 over n squared of I plus 5, and then the sum of I equals, and then the limit. Remember, we're taking the limit, so let's put it just in case. Let's just put it. So lim as n approaches infinity of that, and then we're gonna do lim as n approaches infinity of 5, and then we'll write the sum 1 just 1, and then we're gonna do n, and then all the way to n I equals 1. I'm going to erase here to continue. So from here we're gonna continue, okay? Then we know from here there is a formula for this sum, and that formula is gonna equal to so we're gonna, okay, so let's see, lim as n approaches infinity of -4 over n squared times the sum becomes n times n plus 1 over 2, and then this sum becomes lim as n approaches infinity of, and then it becomes phi over n times n. Okay. So here we can get rid of this n here, and becomes n, this becomes 1. So this becomes lim as n approaches infinity of -4 over 2, that becomes -2 times n plus 1 over n plus lim as n approaches infinity of phi so here we set we do lim as n approaches infinity of -2 plus minus 2 over n. And then the limit as n approaches infinity of phi is just phi. Now we take the limit of this, we're gonna get -2, and then this limit becomes 0, so it becomes plus 0 plus phi. The sum becomes -2 plus phi, that is equal to 3, and that's the final answer. So the area is equal to 3 within this interval and bounded by -4x plus phi and the x-axis. So that's all we have to do. We have to compute the area using limits and sums. Thank you very much, students.